Europa, one of Jupiter's moons that is not in the Goldilocks zone, stays warm. Jupiter and the moons that orbit around it are actually sending energy to Europa. Astronomers have been interested in Europa, Jupiter's interesting moon, for a very long time. From the time it was found in 1610 until the Voyager trips in the late 1970s, there were hints that there might be an ocean below the ice. It took decades of research and study for the James Webb Space Telescope to make its amazing 10-hour view of Europa. What hidden things did this long study show? Could it show that there might be life beyond Earth? What kind of sign is this? Watch as we look into how the Webb Space Telescope looked at Europa for 10 hours and then saw what might be a sign of life. Europa is one of more than 90 moons that Jupiter has. It is the sixth moon that is closest to Earth. Io, Ganymede, and Callisto, Jupiter's other three largest moons, were the first moons found outside of Earth's orbit. The Galilean moons were discovered in January 1610 by an Italian scientist named Galileo Galilei using a telescope that he made himself. The surface of Europa is mostly made up of silicate rocks, and it probably has an iron-nickel core inside the water ice. The air around it is pretty thin and mostly made up of oxygen. There are dark reddish-brown cracks all over Europa's water ice surface. The moon's surface doesn't seem to be more than 40 to 90 million years old, based on the few craters that have been seen. This is very young in geological terms, that's for sure. Under Europa's icy surface is an ocean of salt water about twice as big as the ocean that covers Earth. So, they thought that Europa might be one of the best places in our solar system to look for life other than Earth. Scientists believe that the salt water below its frozen shell holds twice as much water as the world's oceans, and may even contain chemicals that are needed for life. A possible situation from decades ago was put forward in science fiction. What if life from other planets thrived in an ocean below Europa's frozen surface? Europa went from being unknown to being the center of attention because of this idea, and it has stayed there. People inside and outside of science are getting more and more excited about the idea of finding life beyond Earth. Using this information, that dream, on the other hand, might be based in truth. Spectroscopic studies done with a telescope at Kitt Peak National Observatory in Tucson, Arizona in 1972 showed that most of Europa's surface is made up of water ice. Thermal models from 1971 also showed that Europa may have a layer of liquid water in its center. Early in the 1970s, the Pioneer 10 and 11 spacecraft flew by Jupiter, but it was the Voyager 1 and 2 spacecraft that took the first high-definition pictures of Jupiter's moons from a distance of about 1.2 million miles, 2 million kilometers. Voyager 1 came very close to Jupiter on March 4, 1979. The satellite took a picture of Europa from all around. A few months later, on July 9, 1979, Voyager 2 flew by Europa. Very close images from the two Voyager probes showed a surface that was brighter than the moon's and had many bands and ridges across it. There were no big impact craters, high cliffs, or mountains on it. We could also say that Europa has a very smooth surface compared to the other ice moons. Voyager pictures only showed a few pack scars, which are thought to form over time as meteorites hit the surface of a planet over and over again for billions of years, until the surface is full of craters. Since there were no large impact craters, it was thought that the moon's surface was fairly new, and that the craters had been removed by something like ice volcanoes or the icy crust settling under its own weight. These amazing finds made people even more excited about NASA's Galileo mission, which took off in 1989 and reached its orbit around Jupiter in 1995. Galileo's main job was to fly by each of the 4 Galilean moons many times. Because the information Galileo sent back about Europa was so interesting, the project was extended for a second journey that would last 2 years and be called the Galileo Europa journey. The rocket went very close to the icy moon 12 times. Galileo's most important finding showed that Jupiter's magnetic field had changed in the area around Europa. This clearly showed that a thick layer of an electrically conducting fluid below Europa's surface is making a certain type of magnetic field. Scientists think that the most likely thing that could be causing this magnetic signal is a huge ocean of salty water based on what's in Europa's ice. Its shell is 10 to 15 miles, 15 to 25 kilometers, thick and floats in water 40 to 100 miles, 60 to 150 kilometers, deep. Even though Europa is only a quarter the size of Earth, its ocean may hold twice as much water as Earth's. The water around Europa is one of the best places in the solar system to look for life other than Earth. During Galileo's visit to Jupiter in the 1990s, no plumes were seen. However, newer observations from telescopes like the Hubble Space Telescope and a reanalysis of some Galileo data have shown that Europa may have thin plumes of water that are thrown 100 miles, 160 kilometers, above its surface. In November 2019, a group of scientists from around the world, led by NASA, announced that they had found water vapor directly above Europa's surface for the first time. A spectrograph at Hawaii's Keck Observatory found the vapor by looking at the chemicals in the atmospheres of other planets by measuring the infrared light those atmospheres give off or take in. If the plumes are real and come from Europa's ocean, a spaceship could go through it to collect samples and study them from space, which would be like studying the moon's ocean. This was done by NASA's Cassini probe on Enceladus, Saturn's moon, which is thought to have an ocean that shoots out into space. In order to keep exploring, the James Webb Space Telescope used two main tools to look at Europa: NIRCam and NIRSpec. The near-infrared camera NIRCam, which is James Webb's main camera, is NASA's replacement for Hubble and Spitzer. Its main job is to take very clear pictures in the near-infrared range of light. NIRCam has two parts, one for wide-field imaging and the other for coronagraphy, a way to block out the bright light that stars and planets give off and show things that are fainter in the background. NIRCam collects light from the first stars in galaxies as well as stars in close galaxies, young stars in the Milky Way, and objects in the Kuiper belt. Its wavelength range is from 0.6 to 5 microns. Astronomers can use NIRCam coronagraphs to take pictures of things that are very dim and close to a central light source, like star systems. Coronagraphs on NIRCam work by blocking the light of a brighter object so you can focus on a close object that is less bright. This is similar to how raising your hand over your eyes in the sun lets you focus on what's in front of you. Astronomers plan to use coronagraphs to find out about the properties of planets that circle stars close by. The near-infrared spectrograph, NIRSpec, on the other hand, tests bands between 0.6 and 5 microns. A spectrograph, which is also called a spectrometer, is a machine that turns light from an item into a spectrum. The spectrum of an item can tell you about its temperature, mass, and chemical makeup, among other things. The object's atoms and molecules leave marks on its spectrum that are unique to each chemical element and can tell you a lot about its physical state. Spectroscopy and spectrometry are two of the best ways to study the world because they can be used to figure out what these lines mean. Webb looks at a lot of very dim things like the first galaxies that formed after the Big Bang. It takes hundreds of hours for Webb's huge screen to gather enough light to make a spectrum. During its 5-year mission, the NIRSpec will look at 100 objects at the same time, which will allow it to look at thousands of galaxies. The NIRSpec is the first space-based spectrograph that can see more than one object at once. Concerning how close Europa's ocean is to its surface, Dr. Goncalves Villanueva stated, "I believe that question has been a major motivator for Europa exploration. This suggests that we may be able to learn some basic things about the ocean's composition even before we drill through the ice to get the full picture." Dr. Goncalves Villanueva is a planetary scientist at NASA's Goddard Space Flight Center. He studies life in space and looks for it on Mars, Venus, ocean worlds like Europa and Enceladus, as well as on primitive bodies, comets, and faraway exoplanets. He is the Assistant Director for Strategic Science in the Solar System Exploration Division. Aside from that, Villanueva is the lead scientist for the Comet Interceptor Missions Instrument, a co-investigator for the ExoMars TGO mission, and the James Webb Space Telescope leader for study on Mars and ocean worlds. Astronomers have already used the Hubble Space Telescope to get early reports of plumes coming from Europa's surface. At first, astronomers used NIRCam to look at Europa while blocking out the light from Jupiter. This was seen on January 9, 2023, when Europa was about 10 hours away from Earth's closest point. James Webb's main screen, which is 6.5 meters tall, was lined up correctly with Europa. During this time, NIRCam and NIRSpec both gathered information at the same time. The experts say that Webb did not find any plumes while it was studying Europa, but that does not mean that there aren't any. Heidi Hamel said, "There is always the possibility that these plumes are variable and only visible at certain times. All we can say with 100% certainty is that when we made these observations with Webb, we did not detect a plume at Europa. Hamill is an interdisciplinary scientist who works on the James Webb Telescope project. She focuses on Webb's topics of planetary systems and how life began. She has used the Gemini, Hubble, Keck, Spitzer, and other telescopes to study the outer planets of our solar system as well as their rings and moons. As a planetary scientist, Hamill knows a lot about how to use Hubble to look at the solar system. She was in charge of the Hubble team that looked into what happened when comet Shoemaker-Levy 9 crashed into Jupiter in July 1994, focusing on how Jupiter's atmosphere changed. Here is a deeper look at what the James Webb Space Telescope found on the surface of Europa. On Europa's frozen surface, scientists found both crystalline and amorphous carbon dioxide. Amorphous means that the form of the molecules is not organized, unlike crystals which have solid patterns. Carbon dioxide is one of the most important things in the world. It is a gas made up of one carbon atom and two oxygen atoms. It is thought to be very important to life because it does things like breathing, metabolism, and photosynthesis. Plus, it's a greenhouse gas that traps heat and changes Earth's temperature. They were first interested in where the carbon dioxide came from. Did it come from outside of Europa or from other places? Since it came from micrometeorites or other things outside of the moon, it was pretty much the same everywhere. In this case, though, it was only in one place. Geologists think that this area is a new chaotic terrain. This is very interesting because it means that something is happening below it. Today's question is how carbon dioxide got to the surface of Europa and why it's only there in one place. Most likely, the carbon came from Europa's underground ocean, which is thought to be a possible place for living things to live. It is thought to be about 100 kilometers deep, and it has more water in it than all of Earth's seas put together. Water stays in the ocean because of Jupiter's tides. Europa's interior is stretched and compressed by its gravity, which heats and powers the planet and keeps the water liquid. In places, there is ice 10 to 30 kilometers thick between the ocean and the top. This ice isn't just sitting there. It's active and broken up with cracks, vents, collisions, and eruptions that let things move between the ocean and the top. The carbon dioxide that was found could have come from a number of places, such as chemical or biological processes happening in the ocean and being carried by currents or jets. It could also have been dissolved in ocean water and released as gas or ice when the temperature or pressure changed. This spot on Europa, close to its equator, is where carbon dioxide was found. It covers about 12% of the planet's surface area. These cracks in the ice let things move back and forth between the ocean and the top. There are several ways that the carbon dioxide that James Webb found could have gotten to the top. It could have been broken down by ocean water and then come back as a gas or ice when the temperature or pressure changed. It could have also been made in the ocean by chemical or biological processes and then brought to the top by currents or jets in the ocean. The carbon dioxide was found close to Europa's equator. This area is called chaos terrain because it has a lot of different types of terrain such as ridges, cracks, blocks, pits, domes, and impressions. Many people think that the ice's jumbled appearance comes from the way it interacts with the water below, which makes it melt, freeze, break up, and refold itself. This area is also one of the busiest and most diverse geologically, which makes it a great target for Webb sensors. So, what does this find have to do with whether or not Europa's ocean is habitable? There may be organic molecules or living things in Europa's water because there is carbon dioxide on its surface. Organic molecules are molecules that have carbon in them. They are necessary for life as we know it. Biological action is any process that uses living things or things made by living things. This is the first time that the Webb Space Telescope has looked at Europa's surface and seen signs of carbon dioxide. So, it may mean that organic molecules or living things are down in the ocean. This is a very exciting find and supports the idea that Europa's ocean could be a good place for life. Amazingly, it may be true that Europa has the right ingredients for life. This groundbreaking discovery brings us closer to understanding whether Europa's ocean could harbor life. The presence of carbon dioxide on the moon's surface opens new possibilities for exploring the complex chemical processes that might occur in Europa's deep ocean. Since carbon dioxide plays a central role in the carbon cycle, which is essential for life on Earth, Its detection suggests that similar processes could be at work beneath the icy crust of Europa. This raises intriguing questions about the potential for life forms that could survive in a sub-zero, dark, and high-pressure environment. The Webb Space Telescope's advanced instruments provide unprecedented sensitivity, enabling scientists to study distant celestial bodies with more precision than ever before. These observations could pave the way for future missions that could directly sample Europa's surface or even drill into its icy shell to better understand its ocean. Understanding the nature of Europa's ocean, its composition, and its potential for sustaining life would significantly impact our broader search for life beyond Earth. As scientists continue to analyze the data from Webb, they will refine our understanding of Europa's environment and determine whether the conditions beneath its icy surface are truly capable of supporting life forms, whether microbial or more complex. This discovery places Europa firmly on the list of prime candidates for astrobiological research in the years ahead.